So, good evening, everybody. Today I will start with my next part, that is the second part of lipid metabolism, and we will be continuing beta oxidation. In the last class, you had heard about uh, the aspect of beta oxidation when you used a saturated fatty acid. Saturated fatty acid, even chain saturated fatty acid. So the issue with even chain saturated fatty acid is that you don't have any double bonds over here. Today we will be discussing what happens if there are double bonds, a single double bond, for example, in the hydrocarbon chain. But before that, I would like to recapitulate last day's class very briefly. With that, I will start sharing my screen. So, we know that the fatty, from here you can see the fatty acyl CoA, the fatty acyl CoA, which is present in the intermembrane space. It will now enter into the mitochondrial matrix through the intermitochondrial membrane. So, this carnitine comes in and CoASH comes out, and it will form again acyl carnitine, that is the fatty acyl carnitine, the fatty acid with CoA. The CoASH is removed and acyl carnitine is there. With the help of these two enzymes, carnitine palmitoyl transferase 1, which will convert fatty acyl CoA to acyl carnitine, and again in the inner mitochondrial membrane CoASH will hit and it will again form carnitine will be released, and again acyl CoA is formed, and the enzyme is carnitine palmitoyl transferase. This we are talking for palmitic acid. This is a 16 carbon fatty acid which is totally saturated, that is there is no double bond. Then with the help of these enzymes, all the first step, second step, acyl CoA, with the help of acyl CoA dehydrogenase gets converted to trans-enoyl CoA, and one NAD is converted back to, and FAD is converted to FADH2. Again in this step, water molecule is needed, and enolase it converts to this enoyl CoA hydratase, it converts to 3-hydroxy acyl CoA. You could refer to my last class to revise once more. And then you find that from the next step there is an NAD molecule produced over here, and a CoASH group comes over, and this is an acyl CoA which is 2 carbons shorter. This is 2, and an acetyl CoA comes out, and you have, if it is 16 carbon, this becomes a 14 carbon from previous day's class, and this cycle repeats and repeats. So, if there are, how many acetyl coenzyme A will be formed if the fatty acid is 16 carbon long? 16 and each step of beta oxidation here, you have 2 carbon going out. So, there are total, what you will find, 8 into 2, there will be 8 sort of sets of 2 carbon acetyl CoA. So, if there is 8 of them, then the cycle must repeat 7 times, because in the last there will be 2 left, that is acetyl coenzyme 8 won't be broken down anymore if you are talking about 8. So basically how many NADH, so this cycle to break down a 16 carbon fatty acid, saturated fatty acid, palmitic acid, you need at least 7 cycles of beta oxidation to have 8 acetyl coenzyme A molecules. So this is the basic accounts of energy spent. Also remember that from a fatty acid to become a charged to become a charged fatty acyl CoA, you needed one ATP molecule, but that ATP molecule, it's broken at the first bond. So it is almost equivalent to 2 ATP molecules. So you get 2 ATP molecules are spent already. 2 ATP molecules are spent to 2 ATP molecule equivalents are spent to form this particular acyl CoA charged fatty acid. And that is what you spend, and rest what you get in beta oxidation is you get at these FADH2 molecule, one FADH in one cycle, one FADH2 molecule, one NADH plus H plus molecule. Now let us see how the calculation goes. So in palmitic acid, which is 16 carbon fatty acid saturated, 7 rounds of beta oxidation takes place. So 7 molecules of FADH2 is produced. In former calculations, it was calculated that approximately 1 FADH2 molecule in the electron transport chain gives rise to 2 ATP molecules. Of course, nowadays they consider this as 1.5, but let us go by the old calculation. So 7 into 2, that is 14 ATPs are formed. Again, 1 beta oxidation gets 1 NADH molecule. So each NADH gives equivalent to 3 ATP in the electron transport chain. So 7 rounds go and you have 21 ATP formed. Then you have since there are 16 carbon atoms, and if you divide it by 2, each acetyl CoA takes 2 carbon atoms, so there must be 8 acetyl CoA molecules formed. So each Krebs cycle, so there are the 8 acetyl means each acetyl coenzyme A enters into the Krebs cycle. So it entered, the 8 acetyl coenzyme A enters, so the Krebs cycle takes place 8 times. So how many 3 NADH are produced in a Krebs cycle? So 8 3s are 21. That is 8 3, and each NADH gives 3 ATPs. So you have 72 ATPs. Similarly, FADH2. So there are each gives 2 ATP, each FADH. So 1 FADH2 is produced in 1. So 8 2s are 16. So there are 16 ATPs are formed. So 8 FADH2 gives 16 ATP molecules, and you have a 1 GTP is formed in Krebs cycle, and that is equivalent to 1 ATP. So 8 of them will give 8 ATP. And so 1 ATP is utilized, but nowadays they consider it as 2. So there is minus 1. So if you do it, it becomes 130 ATP. So according to this calculation, it is minus 130. But some books you will find that they make it 129. They take it as minus 2. And in some books you will find this calculation as different, because they consider 1 FADH 2 molecule to give 1.5 ATP. So there the multiplication instead of 2 will become 1.5. And keep in mind that in some books it is minus 2. They consider it as 2 ATPs taken. So they subtract 2 ATPs. So this is a recapitulation of previous day's class. Now let us go to today's class. So beta oxidation of unsaturated fatty acid. So let us have a look at an unsaturated fatty acid. Let us have a look at an unsaturated fatty acid. This is delta 9 oleoyl CoA. So already it has been charged with a CoA SH. It has been already charged. It's at 9 carbon. This is the first carbon, second, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Here there is 18 carbon, and on the ninth carbon, the double between the ninth and the 10th lies the double bond. So what happens is 3 cycles of beta oxidation takes place. This 2 is gone, next cycle this 2 is gone. So 3 cycles of beta oxidation takes place. Imagine 3 NADH molecule is formed, 3 FADH2 molecule is formed, and all these energy compounds are formed. Imagine, so this is how the energy is formed, and 3 acetyl coenzyme A enters, and so there are 3 times the Krebs cycle takes place, whatever happens. Now 3 acetyl coenzyme A molecules are removed, so it becomes shorter now. Now you see the first carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 18 minus 6, that is 3 into 2, 6. It becomes 12. So there are 12 carbon is left. So this is cis delta 3 dodecanoyl CoA. This is the name of this compound. So this is, here is carbon 3. So it is delta. Cis configuration means if you could draw a hydrocarbon molecule like this, this is a cis configuration. That is, these 2 hydrogens are on the same plane. And if it is trans, then the configuration is in the other way around. So the trans molecule goes in this fashion. So this is a trans configuration. So when it is cis, it is in this configuration. So you can see that over here there is a hydrogen. Here there is a hydrogen. So this is drawn over here in this part. So this is this compound 1, 2, 3. Now this enzyme enoyl CoA isomerase, it works now. What does it do after working? It reconfigures, and this is converted into a trans configuration. You can see the hydrogen atom was before it above, it comes below. So a trans configuration takes place. Right, but now the double bond has now shifted. You see, this is carbon 1, this is carbon 2. So the double bond starts from carbon 2. So the trans delta 2, this was delta 3 here, now it's delta 2 dodecanoyl CoA is formed. In the next step, since once this double bond is formed, hydratase comes and this hydrogen is added and this double bond disappears. 2 hydrogen molecule is added and it disappears, and you can see that the compound becomes like this. After this, two carbons are going out every time. 1, 2, 3, 4, 5. So there are 5 cycles of beta oxidation taking place, and that means in the end 5 acetyl coenzyme A plus 1 which is remaining, that is 6 acetyl CoA is produced. So this is the end product when there is an unsaturation. This is how beta oxidation takes place in this compound. With this, I will after this I will stop my class over here. But on the next day, I will be talking about when there are many double bonds present. You had talked about a single unsaturation. That means a single double bond is present. We will talk about polyunsaturation. Then after that, we will be talking about oxidation of odd carbon chain fatty acid in the following classes. So I would request you to look and see, read. I've already posted this in the Google Classroom, and I will post you the figure also in the Google Classroom. And what I would also suggest you have a look at these videos on YouTube. I will post you the link in the Google Classroom itself. So does anybody have any questions? Please raise hands. Shambhavi is asking, but sir, as ATP is a form of energy and energy is never negative, but here there is a balance of -1 ATP. Energy is not negative, but you need energy. So -1 ATP which you see, or -2 ATP in some books which you see, it is that amount of energy which you have to give them. So from your whole body, maybe 2 ATP is removed for one cycle of beta oxidation to charge a fatty acid. 2 fatty acyl CoA was 2 molecules of 2 ATP equivalent energy is taken. Energy cannot be negative, but if you gain energy, you can say that it's positive. If you lose energy, you can say negative. Like money cannot be negative, money is positive. So if you get money, you are on the positive bank balance. If you take a loan, if everybody takes, your bank balance becomes negative. That means you have to give more energy to make your bank balance zero. So the question is like that. I hope it answers your question. দেখি সম্ভাবীকে দিয়ে, সম্ভাবী ask the question once more, বাংলাতেই জিজ্ঞেস করতে পারো।
না স্যার ঠিক আছে, অ্যাকচুয়ালি বিটা অক্সিডেশন অফ পালম্যাটিক অ্যাসিডের লাস্ট স্টেপে যেখানে ছিল যে 1 ATP ইউজ ফর অ্যাক্টিভেশন অফ FA ইজ -1,
ওটা কিন্তু লাস্ট স্টেপ নয়, ওটা কিন্তু ফার্স্ট স্টেপ। Fatty acid is getting converted into fatty acyl CoA. Remember, 1 ATP has been taken already.
আচ্ছা, মিন্স ওটা কি যেন বলে, contextual way তে নেগেটিভ নিচ্ছে ওটা।
Exactly, contextual. Energy is not negative.
আচ্ছা আচ্ছা, ঠিক আছে।
When I will talk about enzymes, I will talk about a little bit about certain rules of thermodynamics. Then you can see that energy is represented negative. Negative energy means that you are gaining energy. And
actually thermodynamics laws এর মধ্যে ছিল like energy is never created nor been destroyed. So that concept was like hitting my mind, so that's why I am just asking the question.
Yeah, this is on a contextual nature, that you are losing 1 ATP molecule. What you are gaining from 1 beta oxidation? Okay, you are gaining 130 ATP, but then you are losing 1 ATP. In some books you will see that it's 2 ATPs. In top books,
electron জন্য হয় ওগুলো 2 ATP.
No, 2 ATP actually is because ATP has got 3 phosphates, right? The first phosphate is known as alpha phosphate, second phosphate is known as beta phosphate, the third is known as the gamma phosphate. Now what happens during beta oxidation, the enzyme hits it at the alpha phosphate. So you basically have, instead of ATP becoming ADP, ATP becomes AMP directly. More, and so you have an inorganic phosphate also released, and then there is an inorganic phosphatase which breaks. There is also one more energy which is produced over there, is utilized over there. So from one molecule of ATP, what you get actually is 2 molecules of equivalent ATP energy wise. So basically in number it is 1 ATP molecule, but you break the molecule in such a manner that will give energy of 2 molecules of ATP. Normally what happens, one molecule is broken, ADP, You have ADP formed and one phosphate. Now what do you over here? What do you have over here? You have one AMP formed, right?
So that is adenosine monophosphate. That is
exactly. And 2-pyrophosphate is released, and that pyrophosphate again breaks, and that will give equivalent amount of energy. So therefore, that is considered energy equivalent to 2 ATP molecules. So 1 ATP is giving energy equivalent to 2 molecules because 2 phosphates are broken here, not 1 phosphate.
Okay.
Anybody, any questions? Anybody else has any questions? Raise your hands. So it seems nobody else has a question. Then in that case, I will end my class over here. And I will send it as usual. So this is the attendance. Let's see all the learners who are there. That's it here. So class over here. End stream.